My name is Marcus Jones, and I'm working as a data scientist here at Ocean Protocol. So this means also thinking about how data scientists would use Ocean Protocol. So I've been doing a lot of core software development, so diving into blockchain programming as well as microservices, and also thinking about how we model AI algorithms, and thinking about some bigger picture stuff as well. So that's related to the title of my talk, which ties in very nicely to what Lawrence was saying, and building directly on what Sebastian presented. So what we have now today at Ocean Protocol, what we've released, and where we're looking to move into. So we're beyond data is the title. So this means I want to get to some more interesting, exciting aspects of Ocean Protocol that excite me. So as you know, we've released version 1 of Ocean Protocol. Maybe you don't know, but we have released version 1. And what this looks like is we have this substrate, the blockchain components, the microservice components. And using this, we can build marketplaces. So we have a demonstration marketplace. Maybe we can show that after during the workshop, but we have a production network running a marketplace. And this marketplace is great for serving static assets like data sets that could be priced or priced at zero, so they're actually free, so commons data sets. And up until now, the focus has really been about building this fundamental protocol to make it robust and flexible, and to demonstrate how we serve data is the current status. But I want to talk about going further, and that was related to what Lawrence was saying, and also some great questions about how does this future really look? So we can also consider the advancement of AI in the most recent years and how quickly it's taking over different things that humans used to be doing. So image recognition, superior to human accuracy, autonomous driving, all of these amazing technologies are powered by AI. And that's related to this talk now. So really thinking a little bit about the future. Also for the workshop, so it's useful to have this sort of in the back of your mind if you want to build on Ocean Protocol, to give you some inspiration and to provide some food for thought about how we can use Ocean Protocol in more interesting ways. So I want to talk just a bit about the motivation, and then talk about what an asset is. So not just data, but what is an asset in Ocean Protocol. So we want to generalize this concept of an asset. And then I want to flesh out a little bit of what Sebastian was mentioning with providing compute on Ocean Protocol, and also talk about the roadmap. So one concept we can start with is this concept of the data economy, which has been touched on very well by Lawrence. And there's a lot to unpack in this concept, this general concept. So we can think about the data economy being related to certain activities that companies and people need to perform in the future and will be more and more popular in the future. So generation of data. So this would probably tie in very nicely with the convergent stack component layers. So generation, collection, storage, getting up to processing, analysis, generating value from data is what it comes down to. And the value, so there have been some studies. In the European Union, the Commission performed a study stating that 2016, 330 billion euros of the European market is devoted to this data economy, or captured by, let's say, the data economy. And then I think we can all agree that this is increasing at a very fast pace with the advancement of things like deep learning, which requires so much data. Again, tying back to Sebastian's slide, like deep learning is super data hungry. And so data is more and more powerful. AI is more and more powerful. So we're looking at several trillion euros, dollars, lots of money, lots of interest, lots of activity. Okay, and then we also had some great questions, so I want to tie back to that as well. So what does this actually look like? So we looked at this convergent stack and these components laid out on a grid. And this, as addressed by the questions in this brief discussion there, was, this can be one way to try to framework it, but in general, I also like this term of AI ecosystem, and maybe it's a bit of a cop-out, like we don't really know how to define it, so let's just call it an ecosystem, but I find it a valuable term because it ties into conceptualizing this future development of data and AI into something, let's just call it an ecosystem. So what is an ecosystem? So an ecosystem for me has many different actors and players. So if you look at the natural world, we're tying into, for example, a forest would have different animals and bacteria and materials, and they're all interacting in very, very complex ways. A key aspect of an ecosystem, though, is that it evolves, it's dynamic, it's anti-fragile. So these sort of tie into, maybe we don't know where the data economy is going, but if we can consider these concepts such as being anti-fragile, flexible, dynamic, and build that into a protocol, build that into Ocean and the convergence stack, then maybe we can be ready to capture where this whole thing is going. And maybe we can support it and in the direction that we provide this as some sort of public utility. So it's permissionless, ownerless, anyone can interact with it and decentralize it. So not just controlled by the FANG companies and other players, but giving power back to the people. Okay, so now let's just do a bit of a technical dive into how Ocean Protocol can support this. So one aspect is, I won't touch on this in this talk, but we have this very flexible concept of a modular service execution agreement, which is an abstraction of a blockchain smart contract, which allows you to add more conditions to your access control. So for example, currently we have a very basic service execution agreement for purchasing data. So it's basically, I want to purchase the data, then the smart contract will ask, do you have enough money for this? And you'll respond, the blockchain smart contract will look at your account, say yes, and then it will unlock that, and then a few more steps and it will start streaming that data to you. But this can be easily expanded to include things like whitelisting, verification of different oracleized information on the blockchain, and you basically have a very flexible tree of conditions that can be used to provide access in the end to different services. And I use the word service and I don't say just data. That's sort of the architecture in a simplified way. We have, I'll just skip this one because we sort of covered it already. So we're talking about the generalized AI asset. So this is one thing that's related to going beyond data. So we have an asset as a general concept, and it's represented on the blockchain with a decentralized identifier. It has an owner. It has some way to verify that asset. This is registered on-chain. Secondly, we have all of the description information for that asset, and that is stored off-chain. And that could be, for example, if we're looking at satellite data, that it could be like the geolocation of that information, which sensor took at the timestamp. And it can also have an endpoint. So for the data case, it would simply be the download endpoint. And that's literally what's happening now in our Commons marketplace, which is running on production. And that is simply going to start streaming that data to you. But actually, this is just an HTTP endpoint. So we can also consider other endpoints. So for example, we can have a service endpoint, which is actually compute. So you purchase this asset on Ocean Protocol. You go through the service execution agreement. Maybe you're whitelisted. You fulfill the conditions. And then you're given access to this service endpoint. So now it's a very generalized concept. What is on the other side of that service endpoint? It could be many different things, including compute, verification, labeling, productionized AI models. So that's taking a step away from just looking at Ocean Protocol as simply being a protocol or a substrate for just data. It's actually for AI assets for this ecosystem that we can see coming. So as a data scientist, this is sort of a generalized, simplified flow of how we work. So we start data, and then we build a model pipeline. So this can be, for example, a Jupyter notebook or Python script, where we take this data, we perform some transformation steps, then we execute this in a compute environment. The result of this for example, a weights file from TensorFlow or some other deep learning library. We use this weights file and we put it into production and we generate value. So this is an iterative process, of course, and it's much more complicated than this simplified diagram. So currently, what we've been focusing on version 1, providing a very robust framework for registering data assets. And that's what currently exists. So we take the data and we can register it. But going back to this generalized asset concept, a lot of other things can be here registered as services. So we can register the data, of course, but we can also register, for example, the Jupyter Notebook. That could be also an asset that is placed on Ocean for a price behind some access control mechanism. Similarly, the train weights file. So if you have a train weights file, so we know that Google has generously donated several of their models. So the Visual Geometry Group, VGG16 models, the 19 models, those are from different universities. So these are models which are free, but we know that these models are trained on huge amounts of compute. So weeks and weeks of hundreds of GPUs, for example, are used to train these. So these are expensive to train, and therefore there could be an incentive mechanism for people to purchase access to them or to just straight up use them. Similarly, even the production can be placed on Ocean as an asset. And this is now, we can also consider this entire workflow as another asset. So when let's say you would purchase this entire workflow as one single asset, which then has pointers to these other assets, and thereby, by one action, you've now purchased an entire workflow, including the model, as a benchmark. So it may be like a starter code for you. It can be used in your business as, we need to, so I know, for example, one company in Berlin needed to predict the customer satisfaction based on the images which were displayed in their hotel booking system. And they spent a lot of effort in all of these steps: data collection, building the pipeline, getting the final train weights file. This, of course, could be very valuable for someone else doing something similar. So maybe a company that has hotel ratings in a different country could use this as a starter code. And so now we're getting to, okay, this data, this is not just data, so I just used the wrong word. So this asset, this is an artificial intelligence asset, which is now currently basically dead capital in a way. So that's something sitting at this company in Berlin. They've used it. Maybe they don't need it anymore. Maybe the company moves or pivots into something else. But what about this amazing asset that they spend all this effort into building? So let's unlock that, allow them, at least give them the possibility to place that on, make that discoverable and allow them to monetize that. Okay, so this is then, just sort of what I, as a data scientist, am actually doing. So it's much more complicated with many, many more steps. This was, I was doing a Kaggle competition and decided to try to visualize how many actual steps do I do. So that's just to break out of this. Really, it's not so simple, but this is to have this as a robust framework allows me to at least consider this as a possibility as a data scientist to productionize more than just my data. Okay, how do we transition here? So this is the prime focus of the development team at Ocean right now. So everybody still working over there on the other side of the room is working on, so we know that this is really an amazing application of Ocean Protocol. So no data escape. What does this mean? And the quotes are intentional. So you can never really, let's just go to the next slide. So it's related to, of course, data privacy and keeping ownership of your data. So currently, when you are on the Commons Marketplace, our production network, you download that asset to your local machine. And of course, at that point, it's yours. There's no cost in duplicating this type of asset. So where does the ownership of that come into play? So this is one way to keep data that is valuable. You can keep ownership of it, but unlock it for data scientists. And of course, it's extremely related to private data. So of course, genetics data, healthcare data, even automotive data that for example, Sebastian mentioned this mobility blockchain initiative consortium. There are many different automotive partners. Why haven't they been able to come together and build this data set of 500 billion miles of autonomous driving data? Well, it's very complicated legally to set up a structure where you can trade this data or give this data freely. And I mean, generally speaking, all they need to do is all the automotive companies need to come together to build this massive data set, but they have not. And it's related to this issue of not just giving your data. Like basically, if you sell your data, let's say if you buy my data on a USB stick, it's basically out there in the world at this point. You can put it on Google Drive or something, and then sell it to somebody or give it to somebody for free. It's just out there. So this is a solution, and that can be encapsulated by just saying, okay, we bring the model to the data. So in essence, we just do exactly that. As a data scientist, I'd build my script. I would send it into the data provider. So let's say it's a hospital. They would train the model on their premise. And that's already very interesting, so they don't have to sign, they don't really need to go to the legal department to say, oh yeah, we need to give access to the data set to this data scientist. Because as a data scientist, I never get access to the data set. I only send my model in, and I get my algorithm in, and I get my model back. So this is really the focus of version 2 of Ocean Protocol. So I have a bit more of a detailed workflow. So on the one hand, we have the, to change the sound. On the one hand, we have the data provider, and compute provider in this case, so it could be a hospital. On the other hand, we have a data scientist that has an amazing model for predicting cancer likelihood based on genetics data or something, right? So we have this amazing, powerful story of being able to save lives, but we simply cannot unlock this data because getting the data from the genetics center in the US and the genetics center in Saudi Arabia and China and Germany to all cooperate together, good luck. So one solution, so for some background, so we have the data scientist, blockchain identity, the hospital has a blockchain identity, we have Ocean Protocol existing components, so we have the keeper node, we have our access control service, we have some file storage, and on the data provider side, we have a compute service manager and some actual compute power, of course, and where the data is stored. So they start by marshaling their resources and registering them to Ocean Protocol. So in this case, they do not register the full data set, they register a sample data set. The sample data set is completely scrubbed of any personally identifying information. So for example, for a genetics data set, it could be randomized gene sequence data, for example. As long as that allows me to build my model, then it's sufficient as a sample. They also would register the compute service. So now both of these things are discoverable on Ocean Protocol, so a decentralized network. So anybody in any country can go and say, okay, this is now available. There's a sample data set and it's linked, so it's a composite asset linked to a compute service. So as a data scientist, I take the sample, I then build my model. So I use this sample data set to test my Python script. So I make sure it works at least on this random data. And of course, my model will also predict random noise because the input is random. However, it at least allows me to build a model or a pipeline which does not cause errors when it's running on the full data set. So I register that as well into Ocean. And then I purchase the compute service, which comes tied to this full data set. I send in my algorithm, my Jupyter notebook, if you will. And on behalf of me as a data scientist, the hospital would then just execute this script. So let's say it's a deep learning model. They would train my model for me. They would also send me a logging endpoint so I can monitor the results. And finally, they would register the result back into Ocean. They could also send it to me, of course. So basically, let's talk about registering it. So they'd register it onto Ocean and delegate ownership back to me. So that's sort of one workflow. And then we get the benefits of having our trained model. So that's sort of a very, let's say it's a starting point. And this then leads to other modalities. So this is like, okay, let's just start with this. And then we can start thinking about all the things that are wrong with this because it's not perfect for all use cases. How can we make it better? How can we pivot into other use cases? Okay, for one example you probably may have noticed, I just gave my model away. Not my model, my algorithm. I gave it to the hospital. If we have a third party that's trusted, so double blind, we could use, for example, some secure compute enclave, SGX. There's many different other alternatives. Let's do third party on-premise compute. So the hospital sends their data to the third party, and they would have to sign an agreement with the local government, perhaps, to conform to regulations. And then I, as a data scientist, send my algorithm to the third party, and the data is there, and then both parties do not see each other's data or algorithms. Federated learning. Take this concept that I just described, multiply it by 1,000 times, and you've got federated learning. For more secure privacy, we can also consider encrypting the full data set to, so again, coming back to the no, in quotes, data escape, we, as Ocean, of course, would not guarantee that this is fully enforceable. So you can, just by virtue of having logs sent back to me, this means I could theoretically leak some information. So the question is, okay, is this okay? Because maybe it's the data set is many petabytes of data and the logging can only output certain, maybe a few kilobytes of data, so we maybe have some leakage as a worst case. So there's more modalities that we can look at. And another thing we could do is not send the model back, but we could actually, as the hospital, we could say to you, we will productionize this model for you and provide an endpoint. So that could be another service which is registered on Ocean. And there's other things that I'm happy to talk about during lunch break. So that's sort of to inspire you to think a bit more beyond data. So for example, this execution of compute, we're now, again, developing. We have an Ocean Enhancement Protocol Ocean Enhancement Proposal in place, which specs out the high-level requirements. So you're free to join this discussion. And let's talk a little bit about the roadmap. So just to take a step back again, we want to unlock data. So we have, just as the shadow, this is a nice Trent slide. So we have the shadow money economy, and so he calls shadow money the Fed. So we want to, just as Bitcoin has unlocked this economy, we want to do the same thing for this data economy. So to unlock this dead capital again. Version 1 was empowering people to use data marketplaces, so again, substrate, to build marketplaces on top, and to provide a data commons. So what about data as a public utility, free for all, permissionless? Version 2, exactly what we're doing now, compute to data, controlling privacy, using service execution agreements in different ways, thinking about these generalized assets. Next, we have incentives and curation. So this is version 3. And so let's just talk about the first 3 ways are actually ways in which we can unlock data, that we can unlock this dead capital in the global data economy. So incentivization, broadening the scopes, and then incentives. Ultimately, what we want to do is, in a sense, make the core development team here obsolete. We want to let the world build on it, and we want to make it fully permission. Oh, I forgot a word there. So to allow funding of different ocean enhancement protocols, that's version 4, and then to make it fully permissionless and fully ownerless. This is the long-term vision. So I'm sure you'll agree that, generally speaking, if you have a transparent and open protocol, I think this can unlock data. So not just trusting Facebook and Google with your data, but trusting a permissionless open network. So yeah, we have a website with that. So back to the motivation. So we talked about the data economy, the AI ecosystem, and that's sort of, just to wrap it up a little bit, again, this was just a presentation to get you thinking about the future of Ocean Protocol, especially as we have this Workshop, so as you're building on Ocean with Sebastian and Jerry, you can think about, as you're registering data assets, you can think about how to generalize this into not just data, but other types of services on Ocean Protocol to unlock data. So thank you very much.